Welcome to the Internet of Things course. In today's lecture, we'll start our discussion about security and privacy in the IoT. And today's topic is focusing on some things which are concerning to a larger amount of the population, surveillance and also the analysis of behavioral patterns using IoT devices and platforms. So, when we talk about IoT, there's an interesting and important challenge here. So if we have personal devices running on the IoT, no matter if it's your smartphone, if it's devices in your smart home, in your smart building, in your office, whatever, if you use these devices, data is provided and data is collected. And very often this data is not staying on the device or not even staying on devices belonging to you personally, but it is extracted, usually without you explicitly knowing it, by whoever might be interested in obtaining data about you. So if you use the IoT on personal devices, you open up opportunities for surveillance of IoT users, and this can happen through the use of single data or also fusion sensor data. So for example, it might be interesting for someone who does advertising or wants to sell your product to know about your GPS position and maybe also about the apps you have installed on your smartphone, which kind of smartphone you're using, your patterns, where you move through the city, and so on. So the questions we have to ask ourselves are, first, can we somehow enable some level of anonymity when we use IoT applications? What is the trade-off between the functionality we actually want to use and the privacy we want to achieve? And finally, which unexpected privacy invasions are in use on IoT devices? So let's get back to the very start of our course, to Mark Weiser, who, as you might remember, is the inventor and one of the researchers who did very early work on what they back then called pervasive or ubiquitous computing. And he already had concerns about the whole privacy problem here. So in one of his papers, he writes, the problem, while often couched in terms of privacy, is really one of control. If the computational system is invisible, as well as extensive, it becomes hard to know what is controlling what is connected to what, where information is flowing, how it's being used, and what are the consequences of any given action. So if we analyze this is exactly the situation we're in today. So we don't have control over the software. Everything's networked, so we don't have control over which data actually makes its way out from your device onto the network. And as soon as it's on some machine on the network, which you don't have control about, where else is your information propagating? And this can happen with like cookies on the net, which are set by advertisers. So you've seen the discussion about cookie banners, and if you look behind the scenes, you see that like hundreds of interested parties are interested in data about you. And it can also happen, especially with data about IoT devices, which can provide much more information about your personal circumstances. So the computational system is invisible, so you usually don't even notice that data is collected about you. It's extensive, so you have sensors, smartphones, networking everywhere. It becomes hard to know what is controlling what, so usually you have to hand off control to some cloud service provided by the manufacturer of the device. You don't know what's connected to what, so you know the obvious connections, but you don't know if these are all the connections or if there are other additional connections somewhere. And as a consequence, you don't know where information is flowing, and you don't know who is using this information and how this is used. So essentially, whatever you do with an IoT connected device can be transparent to people you've never met before. To summarize this, with deeply embedded devices such as IoT nodes and smartphones, you as a user have no control over how your data is processed and distributed. And even if you're an experienced user, say if you happen to be knowledgeable about, well, networking, about embedded devices, IoT devices. So with all the knowledge we provide you here, you still have very little chance to gain more insight, since first the source code for most IoT appliances is not available, so you cannot actually check what's going on. So there's some sort of firmware blob on your device, and if it sends out all your data over the internet, it's hard to check. Of course, you could try checking the internet traffic from your devices, but then again, this could be encrypted, so this is very hard to tell what's really going on. So we have a number of privacy issues in the IoT, and here's just a list, which is probably not complete, but it gives just an overview of the breadth and the, well, variety of the problems we have when we consider privacy in IoT. So the first problem is that we simply have too much data. So the amount that IoT devices can generate here is really outrageous. So there's a Federal Trade Commission report in the US entitled Internet of Things, Privacy and Security in a Connected World. And this found out that fewer than just 10,000 households in the US can generate 150 million discrete data points every day. So back in our database part of the course, we talked about big data. Now this is obviously big data. And of course, this creates entry points for hackers, for malicious actors, even if they have more or less legal access to your data. And of course, it can leave sensitive information vulnerable. We have an unwanted public profile. So you all know these terms of service that you have to agree to when using, well, a website, a cloud service, or ordering some stuff. And of course, nobody's going to read through dozens of pages of legalese text. So you all probably have agreed to some terms of service at some point, but you actually don't know what you have agreed to. And very often in these terms of service, some very malicious points are included, like, well, your contract partner with these terms of service is allowed to share data about you, your purchases, and so on with whatever third party this company might be interested in. So if we look at this aforementioned FTC report again, this found out that companies could use collected data that consumers willingly offer to make employment decisions, for example. So, if, for example, a company or you apply for a job at a company and that company does a background check about you and buys some data from a data broker, and this data might include your purchases at, yeah, a pharmacy, for example. And let's imagine, just for a moment, you are a woman and you bought pregnancy tests. So maybe that's the reason why you didn't get the job, because if you bought a pregnancy test, there's a certain probability that you might be pregnant as a woman. So essentially, maybe it's better not to hire you because you might be not able to work for a couple of months. Well, this is highly illegal, obviously, but nevertheless, it's highly illegal in Europe usually. Nevertheless, it might be legal in parts of the US. And of course, no matter what, if it's legal or illegal, people still try to do it, especially companies. Another example might be an insurance company that might gather information from you about your driving habits. So most modern cars are connected to the internet using some sort of 4G, 5G technology and a SIM card in your car. And well, just by obtaining your movement profile, obviously somebody can figure out how fast you've been driving. So if you're a fast driver, so if the system figures out that you can get from location A to location B, whatever, with an average speed of 200 kilometers an hour, then you will be surprised that your insurance rates are going up. This is information nobody should know about you, except for maybe the police, right? And the same could also occur for health and life insurance because your fitness trackers were just sending out data you didn't want to be sent out, and so on. Of course, it can be even worse. So essentially, companies could try to eavesdrop on you, so to listen to conversations inside of your home or your office. So this can either happen by manufacturers. So if you have something like an Alexa smart speaker, well, it does speech recognition, right? But most of that speech recognition, except for the Alexa keyword, is not happening on the device itself, but data is sent to the cloud. So your speech samples are stored somewhere in the cloud, and of course, they're not deleted immediately after. You can even check on your Alexa app which speech samples were recorded and how they were detected. And well, if it brings money, well, the provider obviously might have an interest in sharing it with, well, whoever is willing to pay money for it. So essentially, you could use a connected device to virtually invade a person's home. And not only manufacturers can do it, as we've seen, IoT devices have security problems, and we'll see this in a bit more in this chapter of the lecture. So, of course, also a hacker could try to gain access to all these microphones distributed over your house and try to eavesdrop on you. And this hacker could be hired by, I don't know, somebody, maybe your wife, who wants to check on you if you don't have unwanted visitors when she's away, whatever, right? And this actually has happened. So some researchers in Germany managed to eavesdrop on persons by intercepting unencrypted data from a smart meter device to determine what television shows somebody was watching at that moment. That might be interesting enough for somebody. And of course, there's more things like with all the ubiquitous video conferences we have now. Have you ever been wondering why, if you muted Zoom or Teams or one of the other video conferencing services, and then actually you produce some loud noise, that you actually got a message, your microphone is muted, please unmute it. So something is listening in the background, even though you assumed that you have switched off your microphone. Well, that's shocking, actually, but it's common nowadays. And finally, of course, this will hopefully lead to a loss of consumer confidence. So don't trust your devices. Each of the problems we've discussed and many more could and will put a dent in consumers' desire to purchase connected products. And this would prevent the IoT from fulfilling its true potential. And I think that's what might be happening right now. So if you can't guarantee privacy and or security from your systems, then, well, customers should be really wary before they even think of buying one of your products, right? So let's look at some possible scenarios for surveillance here. We've mentioned this on the previous slide. So fitness trackers. So these little armbands you can use to check your pulse and whatever else, blood pressure and so on, connected to, well, yeah, the some other IoT devices using Bluetooth usually. So fitness trackers actually are able to collect very sensitive data about your health. So a Fitbit tracker, for example, can collect the numbers of steps you take, the distance you travel every day, the calories you burn, your weight, your heart rate, sleep stages, active minutes, and location. Of course, other devices that have this functionality, like a smartwatch, can also do this. Now imagine your health insurance company would gain access to this data and would figure out like, oh, Dan, well, since you just signed this health insurance contract, you gained 10 kilo, you're not really doing exercises regularly, your blood pressure is too high, whatever you might imagine. Then, of course, this creates what we call an information asymmetry. And this is always to the disadvantage of the user, so to your disadvantage. So a company suddenly knows something about you that you wouldn't even tell your best friend, maybe. And of course, this company will make use of it. So obviously, insurance companies would be very interested in your health data in order to increase the rates you have to pay every month for your health coverage, or even deny coverage based on your current and on your previous behavior of the customer. The same in our other example, of course, for insurance companies for car insurance. And the perverse thing about this is, of course, insurance companies already provide free health trackers that exactly do this thing. So they provide information about you to the insurance company, and they even have the audacity to actually advertise this as an advantage to you, right? Because you can get a rebate of €2 a month when you use our health tracker. But of course, they never tell you about the disadvantages. I was once asked by my by my car insurance company if I would be interested in such a contract, which gives me a minimal rebate of like 10% if I agreed to install a tracker in my car. And when I told them, I'm a computer science professor, and whenever you try to force this to me, I would be out of, I would no longer be a customer of your company in the next second. But I don't think they're going to think about this anymore because, like, as long as it provides an incentive to earn more money, then the surveillance is an option for these companies. So the only solution to avoid this is to outlaw this. But of course, there's pressure from industry. So now in Germany at the moment, so this pressure from industry is especially strong here, and the influence on politicians, well, obviously will not lead to a legislation which is privacy friendly, friendly to the customer instead of friendly to industry. So this is very problematic, and this might actually be a motivation for you not to use IoT devices, and I can fully understand this. Even though the technology and the options might be interesting, essentially what we would need in the end is a privacy-friendly IoT, which is under your control, which doesn't hand out data to the internet, and is still interoperable and functional. This is a research problem, a difficult one, but I guess a company that would try to implement something like that might be very successful. Of course, it needs to be able to prove that it is actually trustworthy. We'll talk a bit about trustworthy software in the next part of the lecture, where we talk about firmware. We'll talk a bit about uh, trustworthy components in software and so on. So essentially being able to supervise what your device is doing. Now, another example, which we already mentioned, is customer tracking in stores. So, of course, this is very useful in some cases, so you don't know where a certain product is located on the shelf, or you have these advanced stores where you don't have a checkout anymore, but just put things in your bag or in your basket. And this is automatically registered, and when you walk out the store, the amount of stuff you bought is automatically dedicated from your customer account. This makes life easier. You don't have to stand in queue at the cash register. But obviously, everything you buy and even everything you put back on the shelf, like you were considering it, and now I'm not going to buy this bar of chocolate and stuff like that, everything will end up, well, in databases provided by the shop, by the company running the shop or the company outsourced to. And of course, this will be sold in turn. So here you have a combination of beacons, of custom mobile apps, of Bluetooth low energy appliances that try to do surveillance. And, well, of course, you also no longer have the opportunity to stay anonymous when purchasing things, especially in the Nordic countries, obviously, where in Norway or Sweden it's pretty uncommon to pay with cash. In Germany, for example, very many people prefer to pay with cash, and of course, cash helps a bit to stay anonymous. It's not perfect, but if you really don't want anyone to know about what you've paid, of course, there might still be cameras somewhere filming you buying stuff, but at least this direct digital data is not provided automatically. But this is becoming the exception rather than the common case. So in very many stores, we have beacons to detect the proximity of a specific customer, even by just trying like a Bluetooth connection or trying to figure out from your Wi-Fi connection attempts which MAC address your device has. Displays in stores can use information about your purchasing behavior, so by mining these big data sets, and they could display personalized ads for you while you're walking by and trying to influence your purchasing decision. And this can result in a significant privacy invasion. So there's an example of a US store. So Target is one of the higher end US store chains for supermarkets. And actually, uh, Target, when this girl was walking by one of the advertisement displays in the store, displayed stuff like baby clothes and baby care to a pregnant teenage girl walking by. And so Target actually knew it before the father of that girl knew that that girl was pregnant. And this is obviously a pretty horrible privacy invasion. And this is what's happening right now. And we need to ask ourselves what we can do against this. Another thing that you might have read about recently is something that started out as actually a very useful device. So this is a product by Apple called the AirTag. And if you read the Apple product description of AirTag, it all sounds pretty positive. So AirTag is a super easy way to keep track of your stuff. Attach one to your keys, put another one in your backpack, and just like that, they're on your radar in the Find My app, where you can also track down your Apple devices and keep up with friends and family. So these things are relatively inexpensive. So one AirTag costs around $29. It's battery powered and obviously it's wireless, and you can attach it to things you want to know where they actually end up. So you can attach it to your luggage when you're traveling. So some people actually found the location of their luggage that was lost in an airport, even though the travel company couldn't find the location of the airport. Or of course, if you have a pet that goes on the loose, like you want to know where your cat is running around, you can follow it, or you can put it well on your keys, obviously. So all this thing does is it uses Bluetooth Low Energy technology. You don't need some long range wireless technology to use it, like lower Wi-Fi. And the thing is, how can this work? So you need a device connected to. So this works because there's a background technology built into every iPhone on the planet. And so as long as there's somebody with an iPhone around, and Bluetooth proximity to the AirTag device, then actually that AirTag can send encrypted location information via the iPhone's internet connection to Apple's Find My servers. So you can actually connect to the Find My servers and figure out the GPS location, at least of the iPhone that connected to it. So the AirTags have no GPS receiver, but they use the location of the phone. So it's not super precise, but of course, like if your bike that you attached an AirTag to has been stolen or if it's still like in your backyard. So of course, this is not the only tracking device. There are other competing products which look very similar. They exist, but the efficiency of such a product obviously depends on the ubiquity of the network behind it. So obviously, Apple only allows its own products to connect to this Find My network usually. I think there might be options to enable third-party providers to get access, but they might be costly. So uh, this all looks pretty good, right? You can find your lost things. So why are we discussing this here? What are the privacy implications of AirTag? Now, here's just a more detailed explanation of how the Find My net works. So essentially, AirTags can connect to nearby iPhones, as I said, using Bluetooth LE. And this does not only include your own iPhone, but to any iPhone on the planet. And we have a couple of billions of them out there, I guess. So an AirTag actually uses its battery and its Bluetooth LE technology to send out Bluetooth advertisement packets, and these are received by all the iPhones in radio range. And an iPhone that receives these advertisement packets actually forwards the encrypted location reports to Apple's iCloud service. I mean, this is encrypted, so that's at least a bit of security. So the random user of that iPhone cannot gain information or access to the location data or to the data that's sent about the AirTag. And then finally, of course, when an AirTag owner connects to the Find My iCloud service, then you can actually figure out where that stuff is hiding or where that stuff is currently at. So, how does it work? What's inside such an AirTag? So, if you want to know what's inside of a modern electronic device, there's a website called iFixit, and they actually disassemble things. iFixit is promoting self-repair of devices, so usually they disassemble things to figure out how easy it is to repair something. So they figure out if there's special screws inside, if something is glued, if something is soldered down, and of course all these points hinder you as the end user, as the owner of such a device, in actually, repairing it yourself. So they actually disassembled the AirTag, and you can see the PCB of an AirTag on the top right-hand side. And it contains a number of sensors and actuators. So there's a three-axis accelerometer, and we have a voice coil with solder points for speakers so it can make a noise. And there's a couple of digital and analog electronics components inside there. So there's a special Apple chip called the U1, which is an ultra wideband transceiver chips, which allows communication with other U1 chips in iPhones. There's a microcontroller built by Nordic Semiconductor, which is a very common one, called an NRF 52832. So this is an ARM Cortex M4 with integrated Bluetooth LE and an NFC controller. And we have an audio amplifier, and then we finally have a battery connector and power regulators in there. So it's a small embedded IoT device that's able to communicate with NFC, with Bluetooth LE, and also using ultra wideband technology. All this for $29. Doesn't sound too bad, right? Now, I guess you already have noticed the obvious problem with AirTags. You cannot only attach them to your own property, but to other properties. So you can put it in the handbag or purse of a person without this person noticing, or you can attach it to a car of somebody else. So it actually allows you to track or stalk other people or other people's property. And Apple has thought about this problem. So, to prevent malicious use, if an iPhone actually detects that there's an AirTag not registered to your iCloud account, and this is not just in the proximity once, but it seems to be following this iPhone, so it sees regular reports of this AirTag, then the iPhone alerts its user, its owner, that there is an AirTag following the iPhone. Additionally, if there's an AirTag separated from its owner for an extended period of time, the AirTag will actually play a sound when moved to draw attention to it. Now that sounds good, right? But are these really sufficient privacy measures? So the first problem is the interval of receiving alerts. So currently, users will receive an alert at a random period between 8 and 24 hours once an unknown AirTag has been detected traveling with them. So you can just follow a person for 8 hours without the person noticing, and maybe even for a whole day. Now, the other thing is, of course, it only works with iPhones. So what if the person that is being tracked doesn't own an iPhone but something else, like an Android phone? There might be solutions for this. So we've given some links to papers and people trying to, investigate what's going on. But there's other things. So of course, security researchers have tried to manipulate the AirTag hardware, and you can actually easily manipulate the AirTag hardware to disable the speaker. So you can manipulate it not to alert. You can also manipulate it, to really not warn you at all. And of course, the other way around, is the Apple Find My network actually secure enough, or can you just build your own device that doesn't alert anyone to connect to the Find My network? So to use all this functionality to track other people or things around, which you should not do. So this is really, really a difficult problem here because it's a useful application, but like all technology, it can be abused, and especially AirTags have been abused more or less from day one as they were available. People are not so stupid that they don't think of malicious courses here. So whenever, well, probably a good reason to buy an iPhone, I don't know, to figure out if somebody's following you, but that's a pretty expensive solution in the end. But of course, it seems to be legal in most countries, so it's not outlawed. So in the end, what can you do? That's a big problem. Should it be outlawed? Do you need improved technical solutions to avoid being tracked by an attack? This is a current discussion that's going on, and yeah, I think that's a problem that will keep us busy for quite some time in the future when these things are becoming even more advanced. Finally, the question is can you actually trust your device? So we've seen all these software switches, and I've also mentioned it before, to disable cameras, to disable microphones. You have all these sensors, GPS sensors, acceleration sensors. How can you actually know that this device sensor is really not providing data to the computer that's inside of your smartphone or inside of your IoT device and whatever? And how can you ensure that only specific apps have access to the sensors and none of the other apps that might be installed somewhere and doing something positive in the foreground, but trying to leech off your data in the background? So, a typical case of what we call a Trojan horse. So, very many applications which don't absolutely don't need access to sensor data still ask for it, and very many users are conditioned to just click OK. So whatever your Sudoku game you install suddenly has access to your camera, your GPS location, and your microphone. I don't think such an application would need this. And it can also be other sensitive information like requests to personal information on your phone, like well, your phone number, your phone identification number, so the IMEI number, or also contacts in your address book. So you would even expose the addresses, the information of other users here. Also, your browsing, excuse me, your browsing history, your IP address, and so on. So, uh, of course, you need to trust your software when it comes to access to data, but when it comes to access to sensor information, then there's another solution. I already mentioned the problem of all the video conferencing solutions actually being able to detect if, even though you muted the microphone, if you're speaking, so essentially the microphone is not muted at all, because that's the only way to detect it, right? And well, some devices actually provide for hardware kill switches. So instead of trusting your software, what you do is actually you insert a physical switch in the data line between the sensor and the computer. And if this physical switch is off, you really disrupt this connection. And well, then, even though an app tries to access this sensor data, no data will come through. So, for example, there is a phone by a company called Purism in the US, which is a complete open source phone based on Linux, and this device is called the Librem 5, and that provides switches to enable or disable the cellular modem, to enable and disable wireless and Bluetooth, and to enable, disable camera and microphone. And of course, you might have used other options before, like just putting a strip of non-transparent tape in front of your camera and your laptop. It's easy for the camera, but take care. For some laptops, that might be dangerous. If this strip of tape is too thick, then it might break your display. That has happened before. But it's much more complicated doing this for a microphone, right? So essentially, applications try to extract as much data. Some applications try to extract as much data as they can from you. And the only way to be really sure that this is not happening is to use physical switches to disable connectivity of the sensor. That's our situation at the moment. And most phones and most computers actually don't have these physical switches to disable the connectivity, so you have to trust the software that's installed on your device. And for lots of this software, you don't have source code, so you can't even check what's going on, even though you would be able to read the code to understand what's going on in the device. Right. And it can get even worse. So, of course, there's a trend towards what we call smart devices. And one example use is smart televisions. So essentially, when you buy a TV nowadays, it's very hard to buy a TV set that's only just a dumb display with a couple of HDMI ports as an input. So usually you have the equivalent of a smartphone or a tablet instead of there running, for example, Android. So smart TV nowadays contains significant computing power. And of course, this can be used for positive things, like it can enable you to watch your preferred TV streaming provider directly on the device without requiring an additional box. But of course, uh, using this technology, your TV also knows which channels you're watching, if you switch away from advertisements, and so on and so forth. Now, to do all this information? Well, it can connect them, collect them, but to send them out, obviously a smart TV needs a connection to Wi-Fi. Now, if you want to access Netflix or other services, you would need this connection anyways, so you can't really control which data leaves your TV. Some smart TVs actually require this also for firmware updates. Some smart TVs actually refuse to actually start up without having internet connectivity. And there have been cases where smart TVs, even though they don't have a connection to an internet, to a Wi-Fi system, well, they actively seek open networks in the neighborhood without you controlling it, and then they connect to the next open network, open Wi-Fi network they can find to send out information about you. And of course, smart TVs can collect audio, they can collect video. So some smart TVs actually check what's on the screen using advanced detection methods to figure out what's going on. They can monitor your TV usage and they harvest your user data, for example, to display unwanted ads in the running TV program, sometimes even replacing the ads that were shown by the TV network providers. And it really does this by using voice activated microphones and by doing picture content analysis. And as I said, finding a dumb TV nowadays, which only displays a picture via HDMI, is hard. And if you find one, it's more expensive than a smart TV because the price of a smart TV is actually subsidized by these surveillance features that are built into there. So essentially, you pay for your cheap TV that you can buy. You're happy about this cheap TV, but you pay for it by selling your data to whoever is the highest bidder on the internet. Now, if you remember your literature courses in high school, you might remember this novel called 1984 by George Orwell. And in this novel, you had the telescreens, which had a two-way connection. So they didn't only advertise propaganda and stuff in this dystopian future that was pictured in this novel, but they had a back channel and could listen to you all the time. And some people think, well, the only thing Orwell was actually wrong about was the year, because we're a couple of decades late. But the situation might be the same. Now, of course, in a democracy, you might think nobody's going to abuse this. But we have all this power of companies, especially social media companies like Facebook and Twitter and so on, really trying to exploit you, to know more things about you, and to influence you. And we've seen all the consequences of this in the last months and years, no matter if it was elections in the US or COVID response, whatever. So essentially, we live in this dystopia, I think. And if you're doing IoT development, maybe that's a great idea for a startup like build IoT devices that are trustworthy, that are privacy conscious and privacy aware, privacy protecting, and that users can actually trust. Now, the problem will be how to build them cheaply so that users will actually buy them. But that's something that needs to be solved. If you have an idea, I think that's a pretty good idea to implement. Now, unfortunately, I need to disillusion you a bit more because these channels that we send information on are still just completely expected channels included in the devices somewhere. So you know which sensors you have. You have an internet connection, even if you sneak it out via an unprotected internet of your neighbor, and so on. But the privacy of users can be compromised not only by directly reading data, but also by just analyzing metadata. This is what we call side channels. For example, even though every piece of data that's sent out by your IoT device is encrypted, so an attacker who is reading your network packets, trying to read your network packets, actually can't really decipher what's going on. The mere presence of a packet or absence of a packet might already provide information. So, for example, by analyzing network traffic patterns, an attacker can try to obtain information about you. As an example, here's a picture showing smart light bulbs. So each light bulb has its own device address. So a device address like a MAC address has to be transferred unencrypted because otherwise addressing devices would not be possible on the physical layers, on the lower layers of our ISO stack. And even if the whole payload is encrypted, Like see the picture below on the lower left-hand side for an example of a payload. Then just the mere transmission of a packet with a device address indicates an event. So usually, for example, a light switch that turns on or off a light bulb doesn't send any information to the light bulb when there's no activity required. So usually you can figure out, like, of course, this is a very simplified case, when there's a packet arriving that's sent to the light bulb, so you can look at the destination device address, then probably somebody has entered or has left the room. So to like try to figure out, like, is this room occupied or is the house occupied? Is the door locked? Have people left the house? And then like a burglar could use this information to, well, invade your home. So this is additional information that's more difficult to get rid of. And we don't have the time to discuss this in detail, but I thought I should at least make you aware that things like these can also happen. And things like these are pretty much unexpected because you don't design this into your system. But still, if you do a security analysis and a privacy analysis of your IoT devices, you should be aware of things like these. So here we can only present a small part of the whole problem landscape. So we've given an overview here from the reference paper that gives much more background about what's going on here, about all the problems here, and there's a number of more problems. So essentially, this is an introduction, but I hope I managed to, yeah, give you some starting points to think about privacy and then finally, in turn, also security in your IoT devices that you're maybe going to develop in the future. So, to conclude, privacy in the current state of the IoT is hard to ensure. You've probably heard data is the new oil, so when you have data, you can make lots of money out of it by just pumping it and using it. Devices can and will spy on you and others, even though it might be a trustworthy device. You might install software on it that's not completely trusted, sometimes or very often actually without you noticing, and even useful functionality can be abused for invading your privacy. Companies and also state actors are interested in your data for doing things like behavior control, with our health insurance example, to deliver ads, but maybe also to constrain free speech. And you've probably all heard of that Pegasus malware that's used to do surveillance of politicians just using zero-day security holds, which would be very expensive on the free market to buy, but this was done by state actors. And it's pretty hard to escape this ubiquitous surveillance nowadays. So probably the easiest way is to throw away all your electronic devices and hide in a hut somewhere in the woods, but that has disadvantages, as you can imagine. So, devices collect and send data without user consent, and there's very few devices that even enable you to use hardware kill or hardware off switches for sensor data in case you don't want to transmit data. So, to be honest, the whole situation is a big mess. It's exploited by companies, by states, by interested actors, and be especially aware of free services because, as we say, like if something's free, you're not the customer, you are the product because data about you is being sold to somebody in order to finance stuff. So maybe this gives you a starting point to think about all the services you're used to use for free every day on the internet. I hope that's not too dystopian for you, but I think it's really, really important to make you aware of all these problems here. Now, in the upcoming lecture, it will become a bit more technical, so we'll talk about some ways to protect at least information and software and IoT devices. So we're going to talk about like how can we do encryption of data in a way that is possible on very small edge devices. So it's not processor intensive, it's not energy intensive, but still secure. And also how can we use hardware features to protect firmware. So running firmware upgrades that try to provide malicious software and so on. So that's the next lecture, and I hope I could get you interested in these topics. And as always, here we have a large number of references today. So lots of them are blog articles or data articles. And some of them might be really interesting. And of course, if you want to start experimenting, like with NairTech, that would be a good starting point. We provided a number of points here. So thanks for listening, and until next time, bye.